Hi, welcome to another episode of This Is My Architecture. My name is Stas and I'm here today with James from Virgin Trains.
Hi.
Hi, James. How about you tell me a bit more about Virgin Trains?
Virgin Trains is a UK rail operator, and we run the West Coast Main Line, which goes from London in the south up to Scotland, Edinburgh and Glasgow. And my team at Virgin Trains, we've recently launched an Alexa skill, so I'm here to talk about that today.
Oh, that's really cool. I have a couple Echoes at home, so you tell me that I can just go and book tickets?
You can, yeah. Initially, we started off just with train times, but we went to booking tickets recently. And yeah, this is the system. So the way it works is we have our customer, and they communicate with Alexa skill after installing it, just by saying, Alexa, launch Virgin Trains. Okay. And that launches Alexa. And what Alexa does for us is it takes care of all the natural language processing, and then we get function calls, simple function calls with arguments, to a core Lambda function. And this orchestrates the running of the skill, and queries the database for various components, makes web service calls, and then returns it back to the user.
Got it. So it looks like this is the Alexa bit. I was wondering what is the responsibility of this DynamoDB database?
Yep, this side here is the front end, the Alexa skill, and DynamoDB here stores some session variables for us. We treat the records in this database as user information, as opposed to bookings and customer information. So what happens is, for example, when a user queries for train times from a particular station, say Birmingham, we store the origin that they've just told us in DynamoDB. And over time, because we have persistent IDs across sessions, we build up a picture of the preferences for users. So if they request train times from Birmingham frequently, then that is information that's held there.
Okay, that's really nice, that personalization. And so I understand, Alexa has the SDK to manage session state, but you do that in a persistent way.
Across sessions, yeah.
Across sessions.
So we wanted to emulate a conversation with a human being at a station, maybe a ticket office. And so we want to build up a knowledge of the customer and their preferences, their likes and dislikes. And yes, we do that in DynamoDB. One of the other reasons we use DynamoDB in this setting, in this context, is because it scales very, very well. And in a seat sale, for example, when we're halving the price of our tickets, we want these two components, the Lambda function that talks to Alexa, and DynamoDB here to scale very quickly and very well.
Got it. Or commute time in the morning. Probably
Indeed,
gets
yes.
crazy. Interesting. And so what happens next if, for example, I decide to say yes, purchase a ticket?
Okay, so the way we work is what we've done is we decoupled a lot of the external services. So we have to communicate with a booking engine, we have to communicate with a payment gateway, and the way we've tackled it is by abstracting those things away from the skill to a backend system. And we use API gateway as an interface using simple REST calls. And so the Lambda, for example, when you want to secure a ticket, it will make a simple REST call to API gateway. And that will then communicate to the appropriate Lambda, which will then go to the booking engine and then back again to read back the train times.
Okay. And so the booking engine is the kind of entity you communicate to understand train times and also actually to.
That's it, yes. So we want to know not only when the trains are, but also the number of tickets that we can sell. So there might be a full train, so obviously we have to know that information. And so the booking engine returns that back to the user through API gateway.
Got it. And what is this database here for?
Okay, so once we have a booking, we treat the user as a customer, and we store those records in RDS. And that information would be tickets, it would be the customer's information about origin destination, whether they need help at stations, because we have a thing called journey care, and that information is persisted there.
Okay. So I think I get the picture. I'm just wondering, well, how do I really pay? Do I just give the credit card details to the Alexa skill, or?
Well, this is one of the things we first asked when we started building the skill. Conversational interface is very new, and obviously, or not so obviously, we don't want to be taking credit card details verbally. It's fraught with potential issues. And Amazon Pay was just an obvious choice. You have an Alexa device, you have an Amazon account. Amazon's a trusted merchant. So we decided to use them as a payment gateway. All you need to do is just say, yes, I'd like to book that ticket. And again, API gateway calls a Lambda function, which goes to Amazon Pay and secures the funds, and then the ticket's purchased.
Okay. So I'm almost about to get my train, but I'm just wondering, like, where do I get the ticket from?
I get the ticket from, yeah. So again, we abstract the services away from the skill. So we call another API gateway function, calls Lambda, and then what we have to do then is build the ticket and send it to the customer. And so the way we do that is we call a function, and that generates a PDF representation of the ticket using booking engine information, which in this case actually comes from RDS. And we build the ticket, we store it in S3, and then using another Lambda function, we build the ticket in the form of an email, and then we send it out over SES. And that arrives in the customer's inbox before they've even finished the skill.
This was really interesting, James. Thanks for sharing.
You're welcome.
Can't wait to test it out.
Do.
And thanks for watching. This is My Architecture.